Alright, on this first wavelength, frequency, and energy problem, we're going to look at barium, which has a green color in the flame, and we're told it has an emission line of 493 nanometers. Now we're looking for the frequency and the energy. Well, let's do frequency first. Well, the formula is lambda nu is equal to c, c being the speed of light. And so frequency, which is nu, is going to be c over lambda. Now, c is 3.00 times 10 to the 8th meters per second. Lambda, on the other hand, needs to be in meters, so it's going to cancel. So I'm going to come over here and say, all right, I have 493 nanometers, and I know that there are 10 to the 9th nanometers per 1 meter. That means that when I run the numbers, I should get 4.93 times 10 to the minus 7th meters. Now, when you put this into your calculator, make sure you put it in as 10 to the 9th, not scientific notation. So then we would put 4.93 times 10 to the minus 7th meters in here. My meters is going to cancel. I'm left with seconds to the minus 1. So when we come down here, we end up with 6.08519 times 10 to the 14th hertz. We have three significant figures, so let's go with 6.09 times 10 to the 14th hertz. That is my frequency. Now the other thing is the energy. Now energy can be done two ways. H nu, H being Planck's constant, and if we substitute nu is equal to c over lambda, then the other way that we can find energy is E is equal to hc over lambda. Now we have generated hertz, so we could take it and carry it through. It's always safer to use numbers that you have, so it'll work both ways, but I'm going to use the E is equal to hc over lambda. So H is 6.626 times 10 to the minus 34 joule seconds times the speed of light, which is 3.00 times 10 to the 8th meters per second. We've already done our calculation over here, so we know that the wavelength is 4.93 times 10 to the minus 7th meters. We run this through our calculator. Energy will come out to be equal to 4.032049 times 10 to the negative 19th joules. Again, we're working in three significant figures, so it's 4.03 times 10 to the 19th joules, and this is per photon. So if we run it E equals H nu, we'll get the exact same answer. So this is the first way to work the frequency and wavelength.